Hey class, we're going to do the last section here for this year. We're looking at inverses of matrices, and we're going to use those to solve some systems of equations by using the inverse of the matrix. So first we're going to have to understand what matrix inverses are, and then also identity matrices. We'll find inverses symbolically by using some row operations, and then represent linear systems with matrix operations and solve those using the inverse. Okay. All right, so first of all, just to understand what an identity matrix is, basically it's just a matrix that when you multiply it by any other matrix, you get the same thing that you started with. So in other words, like in the real number system, we call the number 1 the identity, multiplicative identity. If I take 1 times anything, I get that same thing back, right? So there's a specific matrix where that happens as well. It's called the identity matrix, and you've got 1s in the main diagonal and 0s everywhere else. So these are some examples of identity matrices, and I think they do state that, I guess, yeah, 1s in the main diagonal, 0s in every other position. So if we were just going to do a simple example of this, so I'll just take this 2 by 2 identity matrix, 1s in the main diagonal, 0s in the other positions. If I was just to demonstrate this and I multiply this out just to show it, remember when we multiply, it's row matched up with column. So I'd have 1 times 1 plus, and then I'd go down here, it'd be 0 times 3, and that would be my first element. And then I'd take this row times the second column, so that would be 1 times 2 plus 0 times 4. And then I drop down to the bottom row, 0 times 1 plus 1 times 3. And then finally I do bottom row and last column, 0 times 2 plus 1 times 4. And what you're going to see happening here is that the 0s and 1s are placed in positions so that I'm just going to get these same numbers back, 1, 2, 3, 4. So this will be 1 plus 0, so I get 1 for the first element. In the next spot, this will be 2 plus 0, so I'm going to get 2 for the next. 0 plus 3, and 0 plus 4. So that kind of demonstrates how the identity matrix works. You just get the same matrix back again. Okay, so now we're going to talk about the inverse of a square matrix. And first of all, they're going to demonstrate it as this. It's when you multiply an inverse times a matrix and its inverse, it gives you the identity matrix. That's the one we just looked at with 1s in the main diagonal and 0s in all the other positions. So to start off, that's the way we're going to they're going to ask us, are these two matrices inverses? And we'll multiply them to see if we get that identity matrix. Sometimes you have a matrix that does not have an inverse, and we would say that it's if it exists, it's an invertible or non-singular, but if it does not exist, we say it's a singular matrix. Your calculator would sometimes give you that. We'll use our calculators a bit for this too, but it'll say singular matrix, no inverse. Okay, so here it says determine if B is the inverse of A. So the way we're going to do that is we're just going to multiply A times B, and actually you can do these either A times B or B times A. But when we multiply it, if we get the identity matrix, then we know that yes, B is the inverse of A. Okay, I wanted to make one other point back here. We're talking about inverses, so for example, like with this statement here, an inverse times a number gives you an identity. So for example, like in the real number system, if I was taking the inverse, and we call it the multiplicative inverse, is another way of saying the reciprocal. So like the reciprocal or the multiplicative inverse of 2/3 would be 3/2. So when I multiply those together, they kind of cancel each other out and make the multiplicative identity, which is 1. Okay, so it's going to be similar with the similar concept, but with matrices now. Okay, so right here, when we multiply these two to test to see if they're inverses, and I go through this process of we're taking row times column, and so as I go through, I have this set up. So 5 times 2 plus 3 times -1, got that. Then we're going to go to first row, second column, so 5 times 3 and 3 times negative 5. 5 times 3 and 3 times negative 5. Bottom row here, negative 3 times 2, negative 2 times negative 3, negative 3 times 2 and negative 2 times negative 3. And then finally, bottom row and last column, so that would be negative 3 times 3 plus negative 2 times negative 5. And if I do the math on this, this is going to be, so this is going to be 10 plus negative 9, so that's 1. Over here, 15 plus negative 15, 0. Negative 6 plus positive 6, 0. And negative 9 plus positive 10 is positive 1. So we see we do get the identity matrix, this 1, 0, 0, 1, and so therefore, yes, B is the inverse of A. Okay, so that's how we can check it. If they say, are these two inverses, multiply them and see if you get that identity matrix. Okay, now to actually find the inverse symbolically, there's a process where we use row operations again. So you set up we've talked about an augmented matrix before, and so we take the original matrix and we put it here, and then we put the identity matrix over here, which is our, ones in the main diagonal, so 1, 0, 0, 1 if it was a 2 by 2. Okay, and then what we do is you use those row operations and try to transform the matrix on the left into the identity matrix, and then what remains on the right side of that vertical line is going to be the inverse of what you started with. Okay, so we'll kind of just walk through one of these by hand. You will be able to use your calculator, but again, like some of these row operations, if they ask you to do some of these, you'll have to be able to do them. Okay, so just the process of how you do it. So you start with your 1, 4, 2, 9, that was our original matrix, and then we put in our identity matrix on the other side of our vertical bar here in our augmented matrix, so 1, 0, 0, 1. And so now what we want to do is we want to translate this left side, and we want to make it so that it's down to 1, 0, 0, 1 on that side. Okay, so we're going to use our row operations, and the first thing we want to do is make a 0 down in this spot where the 2 is. So to do that, we're taking row 2 minus twice row 1. Okay, so back here, if I take row 2 minus twice row 1, so that would be 2 minus 2 times 1, so 2 minus 2, I get 0. And then 9 minus 2 times 4, so that would be 9 minus 8, that gives me 1. And I'll have 0 minus 2 times 1, so 0 minus 2, that's negative 2. And then 1 minus 2 times 0, that's still going to be 1 minus 0, that's still 1. Okay, so when we did that, we got a 0 here and a 1 here. Those are both things that we needed. Okay, so we're just kind of recopying that same matrix down here. And then the last thing we're going to do is we're going to take row 1 minus 4 times row 2 because we want to get a 0 in this position now. So we're taking row 1 minus 4 times row 2. So that's 1 minus 4 times 0, that stays 1. 4 minus 1 times 4, so that's 4 minus 4, that gives us 0. 1 minus 4 times negative 2, so that's 1 minus negative 8. 1 minus negative 8 is 9. Okay, and then 0 minus 4 times 1, so 0 minus 4, negative 4. Okay, and now I've got my identity matrix on the left side, and what's left on the right side is the inverse of the original matrix. Okay, so right here, this is the inverse. So A inverse is the matrix 9, negative 4, negative 2, 1. Okay, and we just use some row operations. You're not going to have to do this process necessarily by hand, but you do, if they ask you to do some row operations, you have to be able to follow through with that, and we'd worked on those in a different video. Okay, and then the other thing we're going to look at doing is just setting up, when we're given a system of equations, we're going to set up a coefficient matrix, a variable matrix, and then your constant matrix. It's pretty easy. The coefficient matrix is basically, as long as these go x, y, z, x, y, z, x, y, z, then they're just in order. 3, negative 2, 4, that's my top row. 2, 1, 3, that's my next row. Negative 1, 5, negative 2. Okay, and then you'll always stack x, y, z in a column in that order, and then your constants on the right side of the equation for all of them, those just go in a column matrix as well. Okay, and as we talk about solving these, we think of as because if I take a times x and set it equal to b, I would get this exact same thing back because I'd be taking row times column. So that'd be 3 times x plus negative 2 times y plus 4 times z equals 5, and that's exactly what I have there. And then I continue through that process with the next 2 rows, and that would just give me the other equations. Okay, so that's an equivalent way of representing that system of equations with variables, or with matrices, I should say. And so now this is actually what we would do to represent that system of equations as a product of your coefficient variable matrix and setting it equal to the constants. Okay. All right. And now it says represent the system here in that same form. Okay, so we want to do kind of like what we just did right here and represent it in this form like this. Okay. So all we need to do for this is just take our coefficients, which are going to be 1, -5, and since there's no z there, we'd put a 0 in that position, and then we're going to put a 2 on this side. And that's going to be actually what it's equal to. I'll wait to do that because we want to put our coefficient matrix in there, in our variable matrix. Okay, and then we've got -3, 2, and 1, 4, 5, and 6. So there's our coefficient matrix, and then times xyz is a variable matrix, and then that's going to equal these constants, 2, -7, and 10. Okay, so there we've set it up in the form A, which is our coefficient matrix, times x, which is our variable matrix, equals b, which are our constants over here. Okay, now for solving, once you do that, you can use an inverse of your coefficient matrix, so our coefficient matrix here. If we find the inverse of that and multiply it, so if we were to multiply it on this side, it would cancel this matrix out and just leave us with the identity matrix. But then we multiply it on this side as well, and when we do that, it solves for the x, y, z, the variables, and that gives us the solution to that system. So that's kind of the idea here. So they show the kind of the steps here. So if I get it into that form, what I just did up above, and then I multiply both sides of this equation times the inverse of that coefficient matrix, the inverse of A, then basically they cancel each other out and leave you with the identity matrix, which is just, then you're just left with your variable matrix here, because identity times anything is itself. And then you just multiply these out and get your solution. It'll turn out to be a 3×1, which is x, y, and z then. Okay, so we'll just kind of show how that works. And we would use our calculator for this one. Actually, we'll do, looks like we're going to do a 2×2 first, and we can do some of that by hand. Now, with this one, this was the previous example where we had found that inverse to be 9, -4, -2, 1. We did that up here in this example. Right here. Okay, so this is where we went through and did it symbolically and found the inverse and came up with that 9, -4, -2, 1 with our row operation. So we're going to kind of just keep going with that one for this example. And so knowing what our inverse was right here, and then if we're going to solve this system of equations, so we'd set it up like what we did before. We're going to take our coefficients of 1, 4, 2, 9, 1, 4, 2, 9, and then times our variable matrix, just x, y, since it just has 2 variables, equals our constants, 3, 5. So on the left side, it's representing a times x, so a times x equals our b, okay? And then what we would do to solve this is, what we do is we'd multiply by the inverse of a on this side and also multiply by the inverse of a on this side. And that basically cancels and leaves us with x here. So to solve, we're going to take inverse of a times b. And so that's what I'm doing here. We found the inverse right here, 9, -4, -2, 1 from that previous example, and then we're going to multiply it by 3, 5. And so when we do that, I kind of went through the work already, but it's 9 times 3 plus -4 times 5, and that's what I'm going to get here. 27 plus -20 is 7. And same thing down here then. -2 times 3 plus 1 times 5. So -2 times 3 plus 1 times 5, that's -6 plus 5 gives me -1. And that's the solution of this system, which means x is 7 and y is -1. Okay, so since we already had found that inverse, this wasn't too hard to multiply, just a 2×2 times a 2×1. Okay, but on one like this where we have a system of equations with 3 variables, we'd probably want to use our calculator on this one. And so we'd set it up like this in our, where we have our matrices representing our system of equations right here. And we'd want to multiply both sides of the equation by the inverse of a, and by doing the left side, that would just cancel here. So we take inverse of a times this b equation or matrix right here, and we'd come up with our solution for that. I just quickly want to, I think I've put this in a calculator already. Let's see here. So if we have, let me just clear this out. Okay, so if I go to my matrix here, in matrix A, if I hit enter on that, oops, I want to show what that is. I think I've got it. I'll just hit edit on matrix A. Okay, so this is matrix A, 1, 3, -1, 0, -2, 1, -1, 1, -3. That was what we had here. Yes, so that's that one. And then in matrix B, so if I hit edit and go to matrix B and enter on that, that was the 6, -2, 4. And so yes, that's what I had for matrix B. Okay, so what we're going to do then to get the solution is we're going to take the inverse of A times B, and that should give us our solution. So I'm going to hit second, quit, and go to the home screen. And so I'm going to hit matrix, and then I hit, just choose A, and under the names tab, then you just choose A. And then you can use this inverse button, which is right here. So hit that, and it puts a little -1 power on it. And then times, and then matrix again, and matrix B is 2. And if I hit enter on that, it's going to give me these values, 4.5, -0.5, and -3. And those are the values for x, y, and z. So it's a pretty simple way to solve a system of equations. Okay, and I think the work is shown here on the next example for that. But yeah, so all that we did was we took the inverse of A times B, and they actually showed, they calculated what the inverse was and kind of showed that. We could do that if we wanted to. If we hit matrix A and then just hit that inverse button. If you want to look at what the numbers are in there, you can hit enter and look at it, but I just did it all in one step and multiplied it so that we got the solution. Okay, so that tells us x, y, and z just as that column matrix, x, y, and z. That's your solution. And I think that is the end of what we need to do. So you will be able to use a calculator to do these problems, but again, you'll be responsible for doing some of those row operations if they ask you to do some. So that's it.